Great. Well, I'll go ahead and kick it off. Good morning, everybody. I'm Bruce Lawler, and I'd like to welcome you to the 5th annual MIT MIMO Deep Learning Workshop. And I'm the managing director of MIT MIMO, and MIMO stands for Machine Intelligence for Manufacturing and Operations. And Stephen, could you go ahead and advance the slides? There we go. And so what we really focus on is driving the shortest path from data to impact. So we're really an applied research group. We're trying to, we are taking new research methodologies and applying them to existing problems. So we're not trying to come up with the approaches ourselves. So first of all, what we'd like to do is thank the team from Meta for joining us today. So thank you very much. I know that you put a lot of work into this this workshop today, and I hope everyone will enjoy it. And Stephen, do you want to introduce the Meta team?
Yeah, sure. So for everyone out there, we got Suraj and Justin with the PyTorch Meta team. Suraj is based out of New York for Meta, and Justin is over in Seattle, and they're with the PyTorch Foundation, and should be a great workshop.
That's great. And Stephen is one of the LGO students that really forms the MIT MIMO team. So we're comprised of a group of students every year that really create activities like this one. Just a little bit about MIMO on the next slide. So go to the next one after that, is there's three big components. So research, so we do field-based PhD research that's sponsored by sponsor companies. We have educational programs like this one for both industry and students. And we try to be field-based, very applied and hands-on. And lastly, we have a lot of collaboration activities. And the goal is really to drive AI and machine learning into manufacturing and operations. So I want to talk a little bit about something we have coming up that's very exciting for all of you, which is our symposium on May 9th. It will be at the Media Lab, and it would be great to have students attend. We have some fantastic keynote speakers. So Jeff Wilke, who is the former CEO of Amazon worldwide. So he went to work for Jeff Bezos in 1999 and continued to work for him throughout the next 22 years and built what most people, other than probably this crew, would know of as Amazon. So Prime, Alexa, the 300 global distribution centers, Whole Foods, et cetera. So we're very honored to have Jeff Wilke with us, Dan Hunlocker, who you all know, the Dean of College and Computing. And this year, MIMO has expanded, and we will actually be hosting this symposium in collaboration with C-Sales. So Daniela Roos will also join us as one of the keynote speakers. So it will be held at the top floor of the Media Lab, as you see there on the left. And I think what's important for you is we have the daytime component, which you'll find on our website. But then starting at 5 o'clock, we host a $10,000 prize competition. And that's a poster competition for students all across MIT. And we're looking for the best applied research of AI and machine learning in manufacturing and operations. So we will have industry judges. And then as part of that, we have what we call MIMO After Dark. So we'll be up there on that beautiful balcony watching the sunset over Charles and having industry participants and students network and really help drive forward and our whole agenda on AI in manufacturing. So please visit our website and register so that you can join the poster competition and join the event, memo.mit.edu. So thank you very much. I'll turn it over to Professor Rama Krishnan. Rama?
Yes, thank you, Bruce. Welcome, everyone. It's great to see this level of interest in the workshop, particularly on a Saturday morning. I saw in the list of registrants a lot of names students who have actually registered for my hands-on deep learning class. So it's really great to see that level of interest as well. Stephen and I have, had many conversations in the past few months with Suraj and Justin as we sort of brainstormed as to sort of the ideal content for today's workshop. And I think I can safely say that what Suraj and Justin have come up with for you today, you're all really in for a treat. I think they cover a whole range of applications, sort of on a sort of a dizzying sort of range from sort of the basics to the cutting edge. So I think it's going to be a fantastic and really sort of stimulating workshop. I also wanted to echo Bruce's sort of thanks to the Meta team. It takes a lot of work to put something like this together. And so, on behalf of MIT Sloan, very grateful to Suraj and Justin to spend the time and their sort of intellectual energy to put this together and deliver it to you today. So with that said, I think I'm going to hand it off to Justin to take it away. Enjoy, everyone.
All right. Great. Thank you, Bruce. Thank you, Rama. Thank you, Stephen, for your introductions. I'm going to go ahead and, in order to start, yes, thank you. I'm going to share my screen. There we go. Are you able? There we go. Okay, great. So you should be able to see presentation. If you're able to see the screen, if you use one of the reactions, thumbs up or something, just so I can see like, hey, you're able to see. Great, thanks. I see them coming in. So yeah, I just want to say again, thank you all for being here today. It's a Saturday, and so I'm really happy that you're here. Saturdays is our, it's a weekend, so I'm really excited to be here sharing this time with you, and we wanted to make it worthwhile today. So, part of, meeting with Rama and Stephen and just brainstorming and trying to come up with some ideas. So, just taking a step back, my name is Justin Jeffress. I'm a developer advocate at Meta, and I have 10 years experience working as a backend developer, and then working as a developer evangelist at Amazon Alexa. And so during my tenure there, Jeff Wilke was there. So when I saw his name come up, I was like, oh, wow. So that's going to be a treat. So, yes. And now I found my way over to Meta. It was a natural transition to go from Alexa to PyTorch and machine learning and AI. So Suraj, would you like to give a little bit of an introduction of yourself?
Yeah, good morning, and thanks, Justin. My name is Suraj. I'm a developer advocate at PyTorch, and like Justin mentioned, what we do is try to talk about PyTorch and different AI/ML concepts that you can tackle with PyTorch, and just help people use it better and get more familiar and actually really enjoy using it. So we really hope that this workshop helps you do that. And we had a lot of fun putting this together, like playing around with some of these technologies. And we really hope that you also derive some enjoyment from this. And special thanks to Justin, because he's dialing in from Seattle. So it's like 6:15 a.m., the crack of dawn. So thanks, Justin, for being all upbeat. I hope you have like gallons of coffee right by you.
Yes, no, I woke up, I took some caffeine. I might step away at some point and grab some more, but I'm doing well. I've got my cats in the other room, and usually when I get up, I feed them. And so they're like freaked out, like, wait, he got up, but he didn't feed us. What's going on? So hopefully they don't get annoying and they don't get picked up on the camera, but they're in the other room, so they won't be making guest appearances and walking across my keyboard. So we're good there. Cool. So here is our schedule of itinerary for today. So this is what we'll be covering. So these times are going to shift a little bit probably here and there. We'll probably make up some time there, here and there. But go ahead and take a screenshot of this so you can refer to it throughout the day. We do have a lunch break set up. And then for each of the workshops, we have some flex time in there. So for each workshop, what we'll do is you'll actually be getting hands-on experience with some of these concepts, and we have some Jupyter notebooks set aside with some instruction wrapped around the different code sections, and we have a solution for each one. So if you get stuck, you can refer to the solution, and then we'll also be around for any questions that you may have. But before we break for the workshops, we'll have a workshop introduction where we'll talk about the concepts that you're going to need to understand in order to complete those workshops, as well as what the problem is that you're going to be solving. So, and then once we break for those workshops, we'll have some time built into that. So let's say, for example, it only takes you 30 minutes to get through, then you have 30 minutes to do whatever you like, whether it's get water, go to the bathroom, do anything like that, get lunch yourself. But if you want to keep learning, it's up to you to keep, or if it takes you longer, don't worry. It's your educational and learning journey for AI and ML is not time bound by just this one workshop. So don't be discouraged if some of the concepts that you're learning today just seem to be pretty deep, because they are, and that you can go really deep and study a lot into this stuff, which is good because it won't get boring. All right. So with that being said, let's get started. So we're going to kick off with a little bit of an introduction into AI and ML. So on Zoom, I think we don't have a chat room set up, but we do have, I think, the ability to send reactions and things. So just wanted to get a quick, just overall sense of how many of you have had experience with AI. If you have, I think there's an option for a yes and a no in the reactions. So if you have experience with AI, go ahead and click the yes. If you have with no, click no, or you can use the thumbs up. So I see some yeses, I see some nos. I think I see more yeses than I see nos. Okay, great. So with that said, what is AI? Well, AI is it's artificial intelligence, and so yes, that's kind of okay. Great. What is that? So basically, it refers to mimicking the behavioral patterns of humans. So if you think about traditional programming model, you define a set of logical instructions, using various constructs like if-else statements that will cause branching, whether a condition is met. And then if something an action needs to repeat, you can create a loop and you can have that repeat over time, but have a conditional that makes sure that that's going to be, continuing until that condition has met. So that's great. However, if something is, outside of that bounds of the rules that you set forth, the conditional logic, it can't really handle those things. And so what artificial intelligence is, it mimics what humans can do, which is fill in those gaps. So if there's something that sounds like we're getting an echo. So if there is a gap in that of instructions, the AI can basically, like a human, infer what needs to be done and handle it accordingly. Okay, great. So the next topic we'll be discussing is machine learning, which is often referred to as ML. So machine learning. So machine learning is a subset of artificial intelligence. And so you can kind of see here in our little diagram here, we have a circle. Instead of using a Venn diagram, we're using, basically a construct where this is a subset of the other. So machine learning, I'm sure many of you have heard of this, but it's kind of a little bit of a nebulous, like, where do you draw this line? But it's basically, a technique which computers can use to learn. So like, you have some data that helps the overall system to be able to figure out like how to handle situations over time. And so, there's different things you can do by having feedback mechanisms to help like get that training data set to help influence those decisions and to fill in more of those gaps over time. So it's like it's getting more and more closer to mimicking what humans can do. So it's like, oh, we get an unknown situation, we can kind of infer something, and then we can also take in new information. And as we take in new information, we can make more informed and better decisions. And so machine learning is that facet of mimicking human cognitive abilities in programming. So that's machine learning. And so we'll be talking about deep learning in a second. But before we get into that, there were some innovations that happened fairly recently. I guess in the computing world, it's not that recent because it's more than 5 years ago. So there was actually, it still takes place every year. How many of you have heard, if you use those same reactions, yes, no, of ImageNet? Got a few yeses in here, got some nos. So ImageNet is one of the largest data sets of annotated images, and yearly they host a competition for seeing who can classify like the most amount of images and do things in a very optimized way. And so this ImageNet, it's a foundation that was created at Stanford, and they have over 14 million images on store, and there's 22,000 categories of images. So, if you're trying to create some training data mechanisms that are going to analyze these things and try to tag them and figure like that's a lot of data to have to handle. And so, one of the benefits of having this challenge is that, if somebody figures out a new way how to optimize that cataloging of that data and that training of that data for AI and ML patterns, the community benefits for it. So they put out this competition every year. And so I think I got ahead of myself, but so anyway, one of the things that it does is it helps drive those rapid advances, right? Because everyone is trying to compete because there is a cash reward that's given up, basically a bounty for the winner. And so in 2012, there was a team called AlexaNet that won the competition, and to win the competition, they created a convolutional neural network. And that was one of the cases that demonstrated the feasibility of creating these neural networks. And neural networks are, I have a slide showing what that looks like in a little bit, but it's a mechanism to mimic the neurons in the human brain. And so it helps make decisions based upon various different algorithms. And so we'll talk about that in a moment. But what was really great about their solution is that they got their error rate down to 15.3%, and it enabled further innovations through being able to use the GPU, the graphics card, which is a much more optimized tool for running these different types of routines than the CPU. The CPU has a lot of overhead. It's competing with various other processes. And so they were able to truly parallelize the operations, and so it made it a whole lot faster.
Yeah, in fact, the AlexaNet architecture was one of the first forays into using GPUs, or highly parallel GPUs, for deep learning. And like Justin said, it really set the ground for much more innovation because we could now do things at scale, and it really unlocked a lot of possibilities.
Yep. And so this is just an overall diagram of the AlexNet. I won't go into too much detail about this diagram, but if you want to dive a little bit deeper into AlexNet, you can go to Google and take a look. How are we for time? Okay. So now we're going to move into deep learning. So what is deep learning? Deep learning is a technique for machine learning that's based on our brains. So it's mimicking those neurons. And so you can see as we're creating that chart, that's not a Venn, I guess you could consider it a Venn diagram, but they're all sort of a union or subset of one another. And so deep learning is contained within machine learning. You can see we're now within the deep learning section. And so what a neural network looks like is like this. So you have all these different neurons, and they have different connections to each and different pathways to another. And they're all sort of trying to figure out which node to get through. So
the deep
Yep.
over here, it refers to how many layers are contained in the network. So over here, it's only 3 layers, and that's not very deep. But traditionally, like when you think about deep neural networks, the difference between what distinguishes it from standard or pre-DNN neural networks is just the number of layers that your data keeps passing through and gets transformed over.
Yeah, and so that raises an interesting question. If it has more layers, does it necessarily mean that it's more accurate or better?
I mean, that's a very architectural specific question, but certainly the more number of transformations that you can do on the data, it increases the complexity of the approximated function, because essentially that's what these models are. They're approximating some real world latent functions. And the general thumb rule is that the deeper the network, the more the transformations possible. And so your nested function approximation can be more complex, which is why we are able to do some of the things that we are going to be doing in today's workshop.
Yeah. So when we get to the object detection workshop, we'll be talking about faster CNN neural networks. So cool. So now at Meta, we are using deep learning. And so if you're using any sort of product from Meta, like Facebook or Instagram, chances are you're interacting with deep learning without even realizing it. So some of those things that are using deep learning are some of the news feed personalizations, the image and video recognition tools. Language translation is another one that is really good for trying to figure out and parse what the meaning of what that sentence was in one language, and then mapping it to meanings and translations into other languages. There's a lot of challenges there because there's not always a direct translation. There's things like cultural references and idioms and all those different things that traditional programming model does not work well with, but deep learning can really help make those translations more accurate. So then there's spam and fake news detection and sort of predictive analytics. So those are ways that Meta is using deep learning. And I'm not going to go into too much detail, but there is a really great article here. If you bookmark the URL here on the screen, that goes into and explains pretty in well detail how the Instagram's Explore recommendation system works. So when you go and you do a search and the little different recommended it's got recommended images and products and things that appear in that list up. It's all done through through deep learning. And so that article is really interesting. So we're limited for time, so I don't really want to dive too deeply into that here today. But if you take a look at that article, you can get a more deeper understanding. So deep learning is not only being used at Meta, it's being used in various other places across many different spheres of business. And so we brought a couple of those to light today. So for example, Disney, they wanted to catalog all the different characters that they have in their wide variety of digital content they have available for various reasons. One, to be able to like have some searches and things for the user to be able to like look up like shows that have a specific character in it, and then also just for their own purposes as well. And so they wanted to basically catalog all of the of their characters, and so they were using they wanted to use deep learning to do that. And so to do that, they were going to create this digital archive called the content genome, and they were using a pre-trained model that, like, they found out that it was pre-trained for faces, like human faces, but it didn't work really well with animated human faces and with animal like faces. So they identified that they needed like a more like a model that could learn more abstract concept of faces. So they identified that they would need to solve that problem. And so they came up with two potential solutions on how to do that. So one was to collect thousands of different faces from all of their animated content. And then the other option was to apply transfer learning from another domain to animated content, which basically, with that second approach, what that would allow them to do is that it would allow them to use the initial training that they had on like human faces, and then augment it with a set of training data for animated faces. And when they did that, they found that they were able to really quickly train the model how to identify in the frames from their animated shows the animated faces. But one thing that came about from that was they also started identifying false positives. So then what they had to do to figure out how to get rid of the false positives was they actually included in their training data, they first trained it with a set of just random objects that were animated. So if they had like a rock or a vase or just random things that were, just appeared in scenes throughout all of their content, that was enough to be able to train to get rid of the false positives. So if you want to go deeper and learn a little bit more about this, you can go to this link that's at the bottom of the slide there. And just one other thing to point out is that they are using a CNN, which is the acronym escapes my memory right now. It's a convolutional neural network.
Yeah.
Sorry.
Get that coffee.
So yes. Yes, it is 6 a.m. here. So, and I am not a morning person. So, all right. So, moving on. So that's how Disney used machine learning, deep learning to catalog different animated faces throughout all of their digital library of content that they provide. And what's really interesting is there's also innovations taking place in the real world. And in places that you might not expect it. So this example here has to deal with farming. And so this company called Blue River Tech created a really cool solution. And you can kind of see it here. There's this big, huge tractor and it's self-driving. And it automatically like detects weeds and eliminates them, which is really, really cool. And so, with farming and with eliminating weeds, there's a lot of like potential problems that can arise where, to the untrained eye, like what is a weed? I don't know. What is a crop? You don't want to overspray, and if you're driving a tractor, right, like you're sitting way up high, you can't really see down to the ground. There's a high likelihood that like you're not going to be able to see, so you're going to have to actually walk along the ground, and it's going to take a lot longer to do this work. And so what Blue River did is they actually used object detection in order to be able to detect like what is a weed versus what is what is crop, and then the tractor actually sprays pesticide on the weed and only the weed. And so this also helps them save on pesticides as well, because they're spraying just the exact amount that they need to just deal with that problem. And it also saves the crop too. So it also helps farmers and dealing with the problem, but also from the economic standpoint as well. So some really interesting applications for AI and ML that are taking place in the world today. And if you're interested in learning about more of these case studies, we have a big list of them up on this index page here. So if you go to pytorch.org/community stories, there's a bunch of different use cases that you can see. So all across autonomous driving, education, and travel are just some of the few that are in that list up. So if you have some time, or if you want some inspiration on what you want to do or how you want to apply it, there's some good examples there. Okay, great. So now that we've talked about some of the core concepts of AI, ML, deep learning, we're going to start talking about applying some of these things. And so we're going to be talking about PyTorch. So PyTorch is an open source library that you can use to build and train your models. So, PyTorch is based on the Torch library. It was developed at Facebook. It was released in 2016, and it makes building and training models relatively easy. Suraj, is there anything else you wanted to highlight there?
No, you covered most of it, but essentially it's an open source library that kept the development experience first and foremost. So it was developed with researchers in mind, because at that time, around 2016, 2017, deep learning was still in a more nascent place. And so one of the USPs of using PyTorch was that it's really easy to put together new architectures and run experiments and really identify what's working in deep learning, especially because it's such an empirical space. So that's something that the library still holds very dear as a core value, that the end user must enjoy using it and building deep learning applications.
Yeah, and that also reminds me, one of the other things when you mentioned that it was an open source project, yes, it was developed by Facebook's AI research lab, but yes, it's now, well, I would say from the beginning it was released as open source.
It's been very open source in its character, in its in the way it's built. Many of the design decisions actually came in from the community. It's very, very much community driven. There's a very thriving large ecosystem of Python projects that build on top of PyTorch for domain specific areas like bioinformatics or reinforcement learning. And so there's a very thriving community that's building things and publishing them in the open.
Yeah, and if you go through any of those case studies, some of the things you'll see is a lot of the times, like in those articles, it'll talk about how they made some innovation and then they contributed back to PyTorch. So I think I'm not sure if Disney did, but I think the other one, it's Blue River Tech. Yes, Blue River. I think they contributed their innovations that they made back into the project. So that's really cool. And then late last year, the Linux Foundation took, so the managing of the project like, I don't know if anyone is familiar, who here is familiar with the Linux Foundation, but they manage a lot of open source projects, and so we transitioned PyTorch over to Linux Foundation. So this serves as a goodwill to the community, because it's like, hey, you know, we may have developed it and open sourced it, but it's not something just that we own and we want complete ownership of. It's just an open source project. So we want more people contributing. We want more people. And so it's like one way, you know, to do that is to open it up to the Linux Foundation and having them manage it. So it's not, hey, this is a Meta or Facebook only product. So cool. So so now that you understand at a high level what PyTorch does, just want to call out some of the well-known libraries. So we have Torch Text, Torch Vision, and Torch Audio. So you can kind of get an understanding just from those names as to what what they handle. But these are various libraries that help you with different data sets for training different things. So Torch Text helps you do things with natural language understanding, natural language processing, understanding, and actually during the workshop today, you'll have some hands-on experience with some of these libraries. Torch Vision helps with object detection, so you can, you know, with that Blue River technology one, with trying to identify like what is a weed and what is pesticide. Like you can sort of see, oh, okay, they must have used Torch Vision for that. And then Torch Audio helps with like being able to detect and translate from like basically speech to text, or identifying things in audio. It's not just speech only. Like there's some pretty cool things that you can do with like taking some music and then breaking it into, okay, here's the guitar track, here is the drum track, here is the vocal. So there's various models that can help you identify different parts of you know, like a song.
And essentially that's the cool thing about deep learning, right? Like previously in analytical machine learning, you were pretty limited by the kind of input data that you could use. Like most typically data scientists would have used tabular data, or they would take any text and they would have to you know, translate that into some form of encoding, like maybe one hot encoding, or just having that in a very tabular structure. And that's a really cool thing about deep learning. You know, it unlocks so many possibilities because you can directly work on information across modalities, and that's kind of shown over here in on this slide. You have text, vision, and audio, which actually corresponds to how we as humans parse information in the real world. And that's, I think, in my opinion, one of the most important characteristics of deep learning, and what differentiates it from anything that was there before. And
yeah. And so with that, like, Suraj, what would you say the typical pipeline looks like?
Yeah, great question, because it's actually not too different from what a classical machine learning pipeline might look like. It starts with getting the data, you know, in the first place, like gathering all of the data that you want to run your analytics on. But before you feed it to the model, which is, you know, a family of mathematical functions, you want to translate the data that you can read, the human readable data, into something that the machine can read. So there are some transforms which again are very specific to the kind of data you're loading and the kind of model it's going into. But essentially you translate your human speak to machine speak, and you store it in a data structure called a tensor, and we'll be covering this a little more further down the presentation. And once your data is captured in this form, it can be sent to the model. And the way these models have been modeled to learn, or the way these models actually do their training, is set to be similar to how humans do it. We don't quite exactly understand how the brain does it, but at a very high level, it makes a prediction and it compares it with the ground truth. And if it was correct, it gives itself a reward. And if it was wrong, it makes some change in how it approaches the data. So and thereby it learns the data. So it makes mistakes and learns from its mistakes. And mathematically, or in calculus, this is it uses differentiation. Specifically, the term over here is gradient descent, and it backpropagates its errors to learn from it and redo it again. So when you do this over and over in a very iterative way, that's called the model training process. And once you have a trained model, you want to ensure that it's correct and it has actually learned what you wanted to learn. So you validate it it's almost like a homework assignment, where you ask the model to make predictions on data it hasn't seen before and ensure that it's actually learning something meaningful. And when you're finally satisfied with that, you can save the model, so that anytime you need to use this, you can just load it right away. You don't need to actually go through the whole training process again. So this is at a very broad level how machine learning pipelines work, exist in deep learning. And this is how you finally get like a model that's trained to make predictions on a topic that you care about.
Great. Yeah. So now that you have an understanding of PyTorch, some of the libraries that are available, and some of them you're going to have hands-on experience with today, and we've covered what the typical pipeline looks like. Just want to point out a couple resources that you can use to get started, just to learn some of the basics. So we have a tutorial that walks through and introduces the basics, and then we also have a quick start tutorial to get just if you want to skip and just get like the minimum steps set up to get started.
Yeah, you have all the steps in one page. So if you want to just see how this pipeline looks like in code, the quick start is a good place to be. And Justin, I actually forgot to mention that one cool thing about persistence is that once you have a model trained, you don't need to train it again. And we will be in this workshop, in today's workshop, we are not going to be doing any model training, and that's because we can rely on pre-trained models. And so you just take a model off the shelf and then you can run your inferences, you can get your predictions right off the bat from there. It saves us a lot of time, a lot of energy, a lot of cost to just take a model off the shelf and use it, ready to go.
Right. Yeah. And to that point, like when I was talking about Disney earlier with their detecting of animated faces, both human-like and animal-like, they were taking advantage of persistence, and they used a library that was already available that could detect human faces. And so because it was trained on human faces, it wasn't quite, so they were able to augment it to be able to work with animated faces, and they were able to do it with a lot less effort than had they had to start from no data to having a solution. So that's one of the really cool things about this is like
that actually points to the community as well, because now you can stand on the shoulders of giants rather than trying to build up things from scratch. And it's a very contributor first sort of mentality, and there are several model hubs where you can find these pre-trained models, and again we'll be covering that in the workshops now.
Cool. Yeah. So with that said, it's now time to get into our first workshop. So great. So what are we going to be doing? Well, we're going to be identifying objects with Torch Vision. So this is one of our first of the libraries that we talked about that we're going to get hands-on experience with today. So, if we were to look at this image, we as humans look at that and immediately know that's a stoplight or a traffic light. Depending upon where you are in the world, you might call it a different thing, but we know what that thing is. And so, that's great. But how does a computer figure that out? How do we use PyTorch and Torch Vision to figure that out? And how do we ask like, hey, is there a traffic light in this image? And if there was, then it'll identify it as such. So how how do we do that? So, well, earlier we showed a typical ML pipeline. So we're going to show you another diagram sort of that's modified to match a pipeline for object detection. Oops. There we go. Great. So this should look kind of familiar in some of the ways, some of the things that overlap, but essentially you have, you know, a input that you need to get from somewhere. So if you look at the very leftmost side, you've got the picture there with the browser window and the web. So in this case, we just got our input image that we're going to look at up the stoplight there off of the web. And so we've got this image, and so we're going to need to do something to do it, because how do computers see images, right? Like, we see an image, you know, and we're able to look at that with our eyes, and our eyes do all of the work of translating that into you know, data that we can then consume. But how do computers see? You know, if you've ever opened up an image in a text editor, you might see something weird and might not know what that means, but basically, you know, there's a mathematical representation of what that image is, and the computer knows how to draw that and render it and change the color of the pixels, so that way your eyes can see and interpret what's the image. So you'll need to do some work to translate this into something that takes it from the computerized representation to the tensor representation. So going back to our diagram, you'll create a tensor for the image. If you have multiple images, I mean to skip slides. If you have multiple images, you can create multiple tensors, and you can batch them. And we'll talk about batching more in detail in a few slides later. Then you use your object model to run the detection. And this is, again, where you can use those models that have been pre-trained and persisted and saved. And so during the workshop, you're actually going to be using a pre-trained model to do that detection. And then once that detection has been made, you'll get basically a data structure that comes back that identifies, that includes a list of data structures that represent the objects that had been detected. And so then you'll need to then process that and figure out, like, okay, what did it detect? And each one of those items that's been detected has a confidence score. So when you're building your model output, you can basically take a look at some of the things that are low confidence, and you can remove them. Suraj, did you mean to set a breakout room?
Oh, yeah. Sorry, I didn't mean to interrupt your flow.
No worries. All of a sudden, this window popped up. Like, what's going on? So, cool. So, yeah. So, like, you know, when you have your model output, like, you can look at the confidence score and eliminate things that have a low score and keep things in the list that have a high score. So, so that's your typical pipeline for detecting things within images. So. What is a tensor? We sort of talked about tensors a little bit, but you know, if you've ever done anything with programming and are familiar with like an array, that's can also be represented as a tensor, and it would be called a rank 1 tensor. Matrix would be rank 2, and a rank 3 tensor is a tensor of tensors.
Yeah,
can also have.
Just one point on that, Justin. Rank essentially refers to like how many when you're writing the shape of the matrix, for example.
Yes.
That's a 2 by 2 matrix, and there's like two
Yep.
numbers in that shape, so it's a rank 2 matrix. The tensor in
Yes.
this image would be a 3 by 2 by 2, and there's 3 dimensions to that, so it's a rank 3 tensor.
Yep. Thanks. So, and then a rank 4, you can kind of think of that one as like a tensor with like a list of tensors.
A list of rank 3 tensors, yeah.
Yes. List of rank 3 tensors. So yes, then Yes, and so the image tensors, you can kind of think of them as rank 3, and each rank has one of these values. So you've got your number of channels, you've got your height and your width. And so what is a channel?
So images
Sure.
are represented. I'm sorry, like digital images are represented either in RGB format or CMYK, and essentially you can think of a color image being a composition of just the blue parts, just the green parts, and just the red parts, and when you put all of them together, it sort of becomes a nicely represented color image. But you can decompose that into channels, and so if you had a black and white image, for example, that would just be a single channel because it's grayscale, right? So the numbers within the single channel tensor or matrix would be values from 0 to 1 depending on the intensity of the white. So like 1 would be like fully white, 0 would be completely black, and intermediate numbers would be referring to different scales of gray or different shades of gray. And
Great.
yeah.
Yeah, so we're basically representing like pixel per pixel.
Each value in these image tensors are essentially values of the pixels. So when you have the width and height of the tensor, that corresponds to the width and height of the image. And again, like every value is a pixel in that image. And one color pixel would be a composition of the values of red plus the values of green and the values of blue. And that's what our model is going to work with. It's going to work with these pixel values. So as we'll probably see ahead, the architecture is a pixel based architecture or pixel level architecture where it's going to be analyzing pixels of the image at a time.
Yes, yep, and we're kind of getting ahead of ourselves, but just wanted to put this in the top of everybody's minds. In a couple slides, we'll talk about that pixel analysis. So continuing on, so yes, so we're going to be using Torch Vision for this. If you want to know more about Torch Vision, you can always get the most recent version of Torch Vision from the stable, or actually it's not the stable. Sorry, I misspoke. The nightly is the most recent. This is the link to the stable version, which is the officially released version, which I think is 1.13, but 2.0 is in the nightlies. And so, yes, it includes a set of libraries for data sets for training data for for recognizing images. And some of them are pre-trained and untrained. So if you want to know more about Torch Vision, you can go to that link on the slide there. So another concept that you'll be learning, and we sort of coined the phrase for this, but to batchify or batching images. So if you think about it, like let's say you had multiple images, and here we have 5 of them. Regardless of like, how do I want to take a step back?
Essentially, like when you have like in the real world, it's likely that you'll have more than just one image, and when you have multiple images, you can do this cool thing called batching. And what that essentially means is that you just group together all of these images. So if you remember the slide, in fact, Justin, if you can move back to the slide where we have our rank 4 tensor, the next one with the rank 4 tensor, you can see that it has 4 rank 3 tensors over here, and that's probably a batch of 4 images. So instead of just feeding one image at a time to the model, you can feed it a whole batch of images. Justin, we can go back to the batching slide. And the reason why this works is, or why this is good, is actually it's going to be illustrated in the next few slides visually, and I think that's better than me talking through it.
Yes.
So
Yeah.
this is the case where you have one image being passed at a time. Now our GPU, it's a device that does parallel processing. It's in fact optimized to do parallel processing. And modern GPUs have quite a large memory capacity. So if you're just using it to process one image, you occupy just a fraction of the GPU's memory, and all of this red space over here is empty space. And empty space means, you know, you're being inefficient. Your
Right.
GPU is going to be consuming the same amount of power, or a little less amount of power, but it's going to be running and we are not using it to the full extent.
Right.
What we actually
Right.
do
So-
want, oh, sorry, Justin.
Oh yeah, no, I was just gonna say, like, you know, we're underusing our resources. Oh, looks like I see a hand up. Joyce, do you have a question?
Yeah, how many images can you batch on a CPU queue that wouldn't slow down the performance?
That's a good question. So on the CPU, we aren't batching. We are queuing them up to be batched, and we'll probably cover that in the next 2 slides or so. But thanks, Joyce, for bringing that up. So just to reiterate, right now what we have is a very inefficient structure where just one image is on the GPU and 5 images are waiting in the CPU queue. What we want, or what is an efficient way of doing this, is in the next slide, where we are occupying the GPU fully and the CPU queue automatically adapts to that. So it has already queued up some images that can go in next. So this is what we want. How do we do this? Next slide, Justin. I think we skipped a slide.
Did it not? Let's see.
Oh,
so
yeah.
Is this?
Yep.
Yep.
So the reason why this is, so what's happening over here is we are taking all of the images that we have, 1 to 5, and then we are clubbing them together into a rank 4 tensor, or a batch of 6 images over here, and we are passing them all to the GPU at once. And the way machine learning models work is that they do several operations on the input images, and all of these operations are independent and identical. And because they are independent and identical, they can be performed in parallel. So if you feed the model 5 images instead of 1, it's going to process all the 5 images concurrently. And essentially what this does is this improves throughput, or how much work the model does in a given unit of time.
Yeah, and so how do we know that these operations are going to be identical?
We know this to be identical because the images that we pass in are going to be identically structured. Now the images don't have to be identical. Of course, it doesn't make sense to do the same thing on, you know, the same image, but they are going to be the same structure. So they'll have the same format, they'll have the same data type, they'll have the same shape. The tensors are going to be of the same shape. So because our operations really only depend on the size of the image or the shape of the input image, it's going to be identical as long as these few characteristics or parameters are identical in our input batch.
Right. So for each batch, so yeah, so I think, yeah, just to spell this out, like for each batch, they have to have identical properties. So the images don't have to be the same, but they have to be the same file type. So if it's a set of JPEGs or a set of PNGs,
well, in
they
this
have
case,
to
it's
have-
just going to be a tensor, so it's not going to be mattering if it's
At that
a
point, it
different
doesn't-
source file type, but it has to be a data type. So the tensor, one tensor can't be a float 32 and the other tensor be a float 64 or an integer tensor. It has to be the same data type.
Right. And so the height and width need to be the same. And so, you know, if you have one image that's 1,000 by 500 and one is 200 by 200, that's not, those operations are no longer going to be identical because,
That's right.
Yeah, we have another slide that demonstrates that. We're kind of getting ahead of ourselves, but just wanted to call that out, that like you don't have to have every single picture or image in your set of images to be absolutely identical. It's your batch has to have identical properties. And again, it's not the image itself, because yeah, it'd be really weird to have a million images that you're training on and they're all the same. That wouldn't do anything. So we're not talking about that. We're talking about the properties. So
and
that allows us to have
this image probably brings back Joyce's question. So Joyce,
Yes.
you asked how many batches can be queued up in the CPU, and
Sorry, what I meant to ask was how many images can be in a batch? So you have 6 currently, but what's the maximum that you can have in a batch?
Oh, yeah, great question. So this is actually determined by what GPU you're using and what is the memory capacity of the GPU. And remember, like the GPU is not only housing the input images, but it's also going to be housing your model. So your GPU memory is going to be occupied by the model and all of the parameters and the weights of the model and so on. And so whatever remaining space is on the GPU memory can be occupied by the image batches. So how many images to a batch really depends on how large your GPU memory space is. And typically in practice, we determine this empirically, because different data types like images or audio or text are going to occupy different amounts of memory. And again, different GPUs are going to have different capacities. So the hacky way we do this is we just run it till we hit an OOM, or an out of memory error. And once we do that, we dial it back, we scale it back, and try to identify that best trade-off of throughput and speed of processing. Which actually brings up a really quick point that, of course, the larger batch, the more time it is going to take for the model to run it. And this is not because of the parallel processing, but due to different nuances of how GPUs are architectured. There's all sorts of different bottlenecks that can make for a really fun presentation, but it's probably out of scope for this one. But the thumb rule is that determine this empirically and try to maximize how much how much utilization of the GPU is happening with the batch size.
Got it. And sorry, one small follow-up question. Like for a typical, MacBook, how many images is too many images to run through the model? Like, is it in the thousands, tens of thousands? Just as a gut feeling, just when I run models, I just want to know how many is too many.
It's probably going to sound like a cop-out, but again, it very much depends on the architecture, the model that you're trying to train, and the domain space. So if it's a very clearly differentiable domain, like let's say, I don't know, classify blue images from red, you'll probably just need a few handful of images. But if it's something way more nuanced, like classify whether this tumor is benign or malignant or dangerous, that's probably going to take a lot more images of a high resolution. So it's probably not a very good candidate to train on a MacBook, but it's very empirical. So you got to try it out and you got to see it. You got to track how the loss is changing over time, and that gives you a sense of whether you need more data or less. I don't know if that is a very satisfactory answer.
No, I got it. Thank you.
Yeah, thanks again for your question. And for everybody else, yeah, if you have a question, feel free to raise your hand. We want this to be informative, but we also don't want to just be talking to ourselves on a screen. So we want to keep this conversational. So thanks again for your question. Cool. So got a few more slides before we get into the workshop, and I think we might be a little bit behind. So I want to make sure that we get to all the workshop stuff today. So moving on to the next thing. So yes, for our pre-trained models that we're going to be using for the object detection, you're going to be using the faster CNN ResNet 50 FPN. Say that 3 times fast. And so, yes, this is a quite popular model that you can use to extract information from an image tensor. So there's a lot of things that you can identify already. And so I don't know, I think in the Disney article, they mentioned which one they use. And I think they combined, they used the Cocoa academic set, but I don't know if they used this one. I think they used HOV or something. I don't know. It's in that article, but anyway, that's besides the point. So you're going to be using a different model than Disney used, but this is that pre-trained data. So again, you won't be training the model today. You're going to be using a previously trained model, and so you'll learn actually how to fetch that model and bring it down locally. And then use that as your data to detect objects within the image that you're going to pass to it. So, and then this is harkening back to like what's unique, not unique, sorry, the operation that takes place at a pixel per pixel level. So if you look on the left-hand side of the screen there, you'll see like sort of like a grid with a dot in the middle, and then you've got like these boxes that are coming out of it. And what is all of the stuff that's going on? Well, what's doing is for each pixel, it's looking at 3 pixels with it's not a 3 pixel width, but it's basically a 3 by 3 box around the center pixel that it's currently looking at, and it looks within that range. And so because it's doing that that operation per pixel, that's why it's identical. And so the reason why you have to have the same height and width is when you create those batches is because it's going to do that exact, depending upon the image size, the number of pixels that it's going to analyze is going to be the same for those. And so, they call that the sliding window. So basically it marks a spot and then it moves that window, then checks, moves that window, then checks, and it does some other things to sort of stitch together and identify like what the object is. And that has to do with...
And this is the fundamental operation that it's doing, like on the sliding window, but it keeps doing this, passing the output to deeper layers that do this again on that output, and this keeps going on and on, hence the depth of the neural network. And what you start with an image, and what you get at the end of that rainbow is images with these bounding boxes around it that the model has detected as objects and also assigned labels to it. So this again goes back to that point that we were making, that the depth of the model really enhances how well it can approximate very complex functions.
Yeah. Great. So moving on, so you'll also be using the Cocoa data set. Suraj, do you want to speak to that?
Sure. Yeah. So this data set, it's an academic data set. It essentially has images which have already been annotated with the objects in them. So this is what the model has used to learn how to identify these specific objects in any image it gets. And the way the models generally output what objects are in the image are by means of integers. So when you run a prediction with the model, it's going to give you let's say 2, and then you got to look up this map which it shows you that 2 corresponds to bicycle, which means the model has detected bicycles in the image. So this is how we'll be using this data set and the model that has been pre-trained on this data set for our workshop.
Cool. All right.
And and inference, it's just it's just a term for prediction. Essentially, you're not training, you're inferring. So you're generating the prediction from the inputs, and in PyTorch, it's very simple. You just take the model and you call. It's almost like a function. So you call that model with the input data, and a line of code in PyTorch would look like what you see on your screen here. And if the input refers to a batch of 3 images, the output is going to be a batch of 3 predictions. If the batch has 1,000 images, your output is going to be a prediction with, it's going to be a batch of 1,000 predictions. Each prediction is corresponding to the input image. And for object detection models specifically, every prediction that it makes on an image contains a list of all of the objects that the model thinks is in the image. And it also assigns a number of how confident it is about its guess of what object it is. So let's say you had a fairly ambiguous image of, what is an ambiguous thing? Maybe a cat, maybe a stuffed toy, which looks like a cat, and the model isn't sure. Like it has features of a cat. It's seen a cat before, and it sort of knows what a cat looks like, but it's not totally sure. So maybe the confidence score that it's going to assign to that is going to be maybe 0.6, which corresponds to like 60%. But if you give it a fairly obvious image of, again, a bicycle, and it's super certain, so it's going to probably assign it a confidence of 99 or 0.99.
Yeah, it's funny when you brought up the stuffed cat example. I was thinking of the Disney faces, right? Because it's like they use the pre-trained model on human faces, and then they realize it didn't quite work well with the ambiguous, like, okay, this is a human-like animated face, this is an animal-like animated face. So
yeah, not to anthropomorphize the model too much, but it's gonna be wondering, oh, like I've seen these features on humans before, is this a person? But it's blue. I've not seen any blue persons before, so it's probably going to downgrade that prediction confidence to maybe 70% or something like that.
Yep. Cool. And then we talked about post-processing before, but part of that process of once you've received or once you have done the detection, then you'll get a report, and then you'll need to go through and analyze like what it found within the image. And so in this particular case, you can see you've got pizza, pepperoni, cheese, like this image that I was looking at. I was hungry when I came up with this example, but you can kind of see that we got it didn't just identify that there were pepperoni slices, there was cheese and other things. And so it's like you can go through and write some code that would then post-process and print out like, okay, here are the things that it determined that were on the image. Cool. And then so the other thing there with the next to pepperoni and with there's a 16. So that's different. The content, the confidence score, that's actually the number of pepperoni that it counted on the pizza. So
it identified this is a custom post-processing function that we have made. So you take the raw output of the model, and then you can manipulate that, or you can massage that into whatever reporting that you or your application needs. So in this example, we're just like reporting the count, the images, the objects detected in the image, and the counts of it, if it's multiple. So there's just one pizza, but there's 16 pepperoni slices on that.
Great. And so with that, we're now at the we're now at the point where you know enough about the different concepts related to torch vision that you'll use to detect different objects. And so we have a link here for you to follow. So I'm going to give you a moment to open up a browser and go to this. I apologize for it being a little long, but give you a moment. I'm actually going to exit out of PowerPoint and open up the workbook for just to give you, those of you, actually, let me get quick sense of the audience. Like, how many of you have used a Jupyter notebook with Google Colab before? So use the yes button. Got a couple of yeses. No. Okay. Got a couple no's. Okay, great. So yeah, what I'm going to do is I'm going to, in just a few, I'm giving people time to type this in. I don't think we have a chat, otherwise I would copy and paste this into the chat, but so apologies that you have to type this out by hand, but I'll close out a PowerPoint. I'll go into the browser and navigate to this GitHub page that will load into, and then load it into Google Colab. And I'll just give a quick, high-level overview of how to go through and navigate through the workshop. So the workshop is self-guided, and there's a set of instructions that you can follow. So, and then Suraj and I will be on the line to answer any questions that you may have. So I'm going to go ahead and minimize out of PowerPoint. Don't worry, I'm going to put it back up on the screen when we're done. So if you didn't get it into your browser, it will be available. And Rama, you came on. Did you have something you wanted to say, or are you able to share this link?
I just wanted to say that if you just type in github.com/fpsample/MIT Workshop, that's enough, because it brings up all the table of contents. They don't have to type in the whole sort of gory detail of the URL.
Good point. Yeah. So if you just go right up to basically FP Samples MIT DL Workshop. Oh,
that's
you can't see my screen over here because it's on the other screen.
Actually, we could see your screen.
Okay.
Yeah.
Are you seeing both of my screens?
I am.
Okay. I see. Okay. Awesome. So, great. So I didn't need to do that. All right. So when you do that, it takes you to GitHub. And so this is not Google Colab. One cool thing, if you look at this here where it says note, we do provide a link to Google Colab. So you can actually click on this. I can't access Google Colab from from Chrome on my work machine. So I need to open up Safari. Hang on just a second. It's because I'm authenticated with a company account that doesn't have access to that. So you can already see, you can see both of my screens, but I want this over here for my, so if I click on Google Colab, if you don't have a Google Colab account, you'll need to create one. Should just be a Gmail account would work. And then, so you can click on that, you can try to add it manually, but we actually have a really cool link here that will open it for you. So if you're doing the file in GitHub, which you are, if you click on that, it'll actually open it up, and now you're ready to go. So, and this opened up the wrong file.
Maybe reload it, Justin. Just reload
Okay.
the GitHub. Yeah.
Yeah, this one's still pointing to me, Suraj. I think you might need to merge.
Oh, okay. Yeah.
Sorry, technical difficulties. You can kind of see the process that we went through. So this is pointing to my personal GitHub repo when it should be pointing to the FB samples. So actually, here's another way that you can do it. If you go up into the,
It
we're already
should
on
be fine
samples.
now.
Okay. On that. Yep. Okay. So there you go. So now this takes you to the Google Colab page. And you can see we've got an introduction of what the concepts you're going to learn are. And then for each step, we have okay, here's some things that you need to do. So we'll need to import some libraries. And the way how you do that, for those of you who are looking at this for the first time, you'll see that every section that's code has this little gray box around it. When you mouse over it, the little play button comes up. So when you click on that, the first time it will say, this wasn't authored by Google, it was authored by us. You can trust us. So in that case, you just click run anyway, and then you won't have to do that throughout the rest of the workshop. But you can see it's loading these libraries here. And so this is essentially running this Python code in this cloud-based environment. So the nice thing about this is you don't have to do anything locally. You don't have to have Python set up. Sometimes, when I've been to workshops, people are like, oh, hey, I'm on a Windows machine and I've never installed Python before. And so it's all of that cuts into the amount of time that they can spend learning. And so with this, we're able to just get right in and go. So we've imported the library. Then the next step is to create the device. And so if you have a GPU available to you, which correct me if I'm wrong, Suraj, I don't think we have GPUs available in our collab, so everything's going to be running on the CPU.
No, we actually do. So there is an option to use a GPU runtime, and the way you can do that is if you go to runtime on the top tabs, you can go to change runtime type, and here you can select your hardware accelerator. So what we want is a GPU, and that's probably if you want to pay for it, Justin. But you will get a standard GPU. It's not going to be very state of the art in terms of how fast it is or how much memory capacity it has, but it does the job, and it does it faster than a CPU. So you can do these steps to get a GPU on the cloud for running this code.
Yeah. So it was runtime. And what was it again that you chose?
Runtime, change runtime type.
Runtime type, there it is. Okay. Just wanted to repeat that for those of you who may have missed that or... So yeah, and you don't have to pay for the premium one. The standard one will work. So cool. And so since I changed my runtime, I have to start over again. So you click that, and then so yeah, you can just go through. There are one thing to note though: don't just go here and click everything, because there are sections where we have you write some code. If you're stuck, don't worry. We do have a solution available. If you look at the top, it says if you get stuck, feel free to refer to the solution. And if you look at the solution will look pretty much the exact same as the other one. But when you go to the code parts where it says, to write code, it instead actually has the code that you have to write. So you can open these up side by side and walk through. And if you get stuck, you can refer to the solution. And if you have any questions, you can ask Suraj and me while we're on the call. So desktop, yes, okay. So we have this really cool thing here that shows you, if you go to 3 where it says get images to analyze, there's this thing here where if you press play, it actually shows you a preview of the image that you just downloaded, which is great. But you'll notice what it does is it imports image from the IPython library, and that overrides our pill image. So what ends up happening is when you go to section 4, when you run the command to load as tensor, it causes an error, and it says that, hey, there's no open, actually this one is, it has no attribute open. So that's because we overwrote the pill image with this other one. So to fix this, you just go up to 1 and you click the play button again, and it will overwrite the image with the pill image. And then once you do that, it'll work again. Apologies, that image preview is cool. It was a late addition, and we didn't think that would overwrite that, but yeah, that makes sense. So again, apologies for that, but that's how you get around that if you run into that. Okay, so it's 11:17. Suraj, are you on the line?
Yep, I'm here.
All right, great. So yes, I know we were kind of running a little. We ran a little over on the description or the intro, and diving into the topics. So we cut the time. So hopefully 45 minutes was enough time. Again, we've got the workbooks, and they'll be available after this. So if you need to come back, you can. And then we also are. We did budget some time for Q&A stuff at the end too. So Any other questions that you may have about the workshop, you can bring up then. But I want to keep us moving so we can get through the rest of the workshop materials. So let me stop sharing that screen and share the one that the presentation is running on. Wrong button. Cool. Okay. Great. Suraj, what did we learn in that workshop?
We learned we shouldn't make changes too late or right before doing a live workshop. But more broadly, I think what we learned is how to load images from disk into Python and PyTorch in a way that our machine learning models can actually grok and process. And how do you actually load the models from Torch Vision? If you did the workshop notebook, you'd see that it's just a single line of code that you need to call, and it automatically downloads the relevant parameters and model weights and just has that ready for you. And you'd have also noticed that there are two modes for a model: training and evaluation. Because we are not doing any training here, we're just doing inference. The eval mode is a more efficient way to use that. We also saw how do you very simply create batches of data. Now in practice, you wouldn't have to do this manually, that is, collect all the data and put it in a list and use that as a batch. PyTorch has a lot of utility functions to do this for you in a very seamless way, where you just maybe feed it the directory of all of your all of your input files, and it automatically collates your data into batches and queues them up on the CPU for your GPU to feast on. And if you go through the 101 that Justin had linked earlier, the 101 tutorial, it has a section specifically on data loading, which covers this stuff. And of course, post-processing, which is pretty important because our models will give out the outputs in a very structured way, but not always in the same structure that our applications need. So we also learned how to, use that output and massage it into a way that is easily readable by humans and probably any other downstream applications.
Great. And just one thing I want to check in. Are you screen recording?
I am.
Good. Okay. I didn't want to get through that section and be like, oh, shoot, we forgot. All right, great. So thanks for that wrap up. So and the next thing we're going to be talking about is a topic that has garnered a lot of interest lately. I'm sure many of you are aware of the topic. So that is generative AI. So Suraj, how would you summarize what generative AI is?
Well, if I had to be a little pedantic, the blanket term generative AI that's being, very popular now, it's a very broad term, but generally any AI technology or any AI algorithm or model that is more of a synthesis nature than an analytics nature probably falls under generative AI. It's been around for a while now, like with GANs. I remember once I was walking in the Stanford campus and I saw posters of missing people, and turns out they were missing because they didn't exist. They were actually created by GANs and hyper realistic faces. So generative AI has been around for a while, but the recent algorithms that have come out are just very powerful.
Cool. Yeah. And when you say synthesis, it's creating something from, as a result. So it's generative AI. It's not generating AI, it's AI generating content. Could that be an output modality? More AI?
I don't know, maybe like AI generates AI, and then you have like your own little ecosystem of AI parents and their AI babies and a little family. I don't know. I don't even know what to expect anymore.
Yeah, so one of the interesting things, it's like now that AI is being able to generate assets, from art to text to audio to a bunch of variety of different things, like that's going to have a lot of impacts on the world. And how do you think that will impact the world? Both, yeah.
I mean, that's a very broad and open question, and
It is.
we are
It's very broad.
we are still adapting as for how new and how widespread this technology can be. I feel like we're still adapting to this new paradigm that's coming out.
Yeah, it's interesting because there's lots of things that okay, you've got I'll just say it, like with ChatGPT, like if you're unfamiliar with that tool, it's a generative AI that you can use to generate whatever you think. Like it's like you could say write a poem, write a sonnet, write something about. You could ask a question like, "What is generative AI?" and it'll actually tell you. And so it's a tool that like writes stuff for you on based on a prompt that you give it. So you might think like, "Oh no, like are people going to forget how to write?" So that could impact the world and people being able to write effectively. But you can also use it as a tool to like collect your thoughts. So if you have thoughts that you're like, okay, here's like 10 different things that I want to focus on or write about, like I can just feed those 10 different things into it, press send, and then it'll write it and wrap it with in a more like cohesive wording that's written out. So like you said, it's still like we're still adapting to it, but I think that there's some positive implications behind it as well. Like, cool. So anyway, when dealing with generative AI, you have different modalities. And so you have an input modality and an output modality. So an input modality could be text, it could be audio, it could be images, videos, 3D assets. So in the case of ChatGPT, the input modality is text. For some of the other tools that you use for generative AI, you can put in an image file, you can put in an audio file, and it will create an output. And there's output modalities, and so those can be things like text, audio. You can have another image. So some of these like generative AI imaging tools are really interesting because you can provide it an image as input, and then you can also provide like some text prompt to say like generate the same type of image. Like let's say you have a picture of somebody playing a guitar, and you want a picture of a cat playing a guitar instead. You could say like, generate an image of a cat playing a guitar that looks like this. And so like the image that you provided. And so that can help.
And some modern architectures, they take multiple input modalities, like what Justin was just mentioning. So you feed it an image of a guitar player and you say, change this to a cat playing the guitar. So that's two modalities. You're giving it input of image and text. And the output modality would be an image in this case, but again, it could also be a image text output where maybe the model also writes a death metal song for felines. So there's a lot of cross play over here, very similar to how humans parse information and process information and generate information across all of these modalities.
Cool. Yeah. So so knowing that, like, okay, yeah, you're not just limited to text, and in some cases you're not, like, you can combine things. So there's lots of potential for different tools that generate different things as well. So I think the big things that people are focusing on right now are like the AI generated art, which outputs images, and then AI generated text. So some of those in the art space that are sort of picking up a lot of traction right now are OpenAI's, who also created ChatGPT's DALL-E 2, and then there's also Stable Diffusion. Not going to go into too much detail other than that they exist. But if you're interested in generative AI art, you can take a look at these projects online. And there's various tools that you can use to interact with them and play around with the different prompts and see what type of images they produce. And so these tools are being made made available to third parties to be able to play with. Like, I could go and interact with this and enter in a prompt and get an image. But there are others who are using generative AI in a more closed manner, in that their output they're sharing, but the input they are in control of. And Suraj and I recently had an interview with Rafiq Anadol from Rafiq Anadol Studios, and he's doing some really interesting things with generating art. So if you look at like this image here, this is artwork that he generated, and he's coined this phrase of making the unseen seen and converting data into pigments to then create new forms of art. And so while this is a screenshot of this, this is actually like animating. And so it moves and morphs from like an image to like these kinds of ebbs and flows. And he combines multiple types of data together. So image data, sound data, smell data, all these different things together to create pictures. And so while this is generative AI, it's not meant to recreate or create a perfect image of something. It's to create a new type of art form.
In fact, Justin, I don't know if you saw, about a week or so back, Rafiq tweeted that he is using a new input modality. He's actually having guests wear headsets, and it's recording their brain waves, and that is the input modality, or that's the input data that his model is using to generate art, which is synchronized with how people are thinking. I don't know what to think. It's so tripped out. But he's using generative AI to create art from people's brain waves.
Yeah, and that's really interesting, because that brings into my next point. Like, we while we interviewed him, we actually asked him if that would be something, not knowing that he was planning to do that. We actually asked him about, like, would that be a modality that you would experiment with? And he was like, well, actually. And so if you're interested in watching that video, you can bookmark this and check it out. There's a long, this is the 32-minute version. There's also a longer, like, full-length interview available on YouTube as well. So bookmark this, come back, take a look at it. But he's doing some really interesting things, and they're using PyTorch as their backend to do all of the model training. So it's pretty fascinating. A lot of really interesting things that they're doing, and a lot of interesting problems that they're solving, just dealing with the amount of data that they take in to create these new forms of art. Cool. So now that we have an understanding of what generative AI is, we're going to go through the workshop that you're going to do for this. So we're going to be creating a video synopsis generator. Ooh, sounds fancy. Suraj, what's this? What are they working on today?
Well, you know that feeling when you come across a really cool video or an interview or a podcast, but it's just so long, and you find it very interesting. You want to know what went down in that conversation. You just want a gist of it, but you don't have the time. So this is something you can you can actually use every day. I do, and it's using AI models to essentially create synopsises or very easily readable gists of any video that you want to watch, but you just don't have the time.
And what is this gist that you're talking about?
The gist is like a summary. It's it's the important themes, I guess. You know, let's say, in fact, if you go to the next slide, some of you might think this interview is also too long. It's 32 minutes, and you just want to get a sense of, you know, what are the main important things that were touched upon it. So either you can scroll through the video real quick, or you can ask AI to do that for you and create like a little report of sorts, which sort of highlights some of the important or some of the themes that were covered during the conversation. So it just would be like the Cliff's Notes, I guess.
Yeah, and I think this is kind of cool. Like, you know, if you're like a content creator, like you're an influencer, you're on YouTube, and you know all you do is heavily like, you know, like, yes, you do the live stream, but then you also need to go back and like have SEO and stuff for all of the, like, what did you talk about in this? And if you're talking for an hour, 2 hours, like that's a big job of like putting all of that and summarizing it into a concise like description. So you can actually use this tool to like go through your videos and do that. So this is one of those things where it's like AI can be really helpful for like, yeah, taking that big conversation and condensing it down into the overall summary. And so that's what you're going to be doing in this workshop. So here is the pipeline of our video summarizer that you're going to create. So your input modality is going to be a video, and you know, we actually don't need to process. We're not running object detection in the video. You know, it's basically just going to be the audio. So we're actually going to extract the audio out, and then we're going to use a pre-trained model to do automatic speech recognition to translate what was spoken into text, and then we're going to use another model that's been trained to summarize text that's been given to it. And then once that's complete, then you'll have a summary. And so you'll learn some more details as we go along. But as you can see here, we're actually using two different AI ML models to achieve this task. So this is pretty cool. Like, you can chain these things together. All right. So in this case, like, to extract audio from a video, we're going to be using a tool called FFmpeg. So we're going to be using the same collab tool that we used before, and FFmpeg is available. So that's really cool. You don't have to worry about installing it on your local machine. And you'll notice in the collab workbook that the FFmpeg command is preceded with an exclamation mark. But if you were to run that on your local system, you actually don't need the exclamation mark in front of it. That's just an implementation detail for that Python notebook. So anyway, when you're doing the workshop, you'll just click the play button and it will download the video file that we provided for you to do the summary with. But you know, the cool thing about this is, like, you're not stuck with using just the file that we've provided. Like, once you've done this, you'll actually have the necessary components to be able to do whatever video you want to summarize. So, and actually, one of the things you could do is you could take the recording from this workshop and put it into, once it's available, you could come back and put it into this tool, and then you have a summary of everything that we've discussed today. So it's kind of cool. All right. And so, yeah, so we'll have a model that's going to, yeah, so you'll notice here, these say the same thing, but the picture here, we've got a speech bubble, and then we've got a box. So this is basically just representing that, like, we're taking the spoken audio, and we're going to convert that into text. And so there's a library that we're going to be using, which is called the Whisper ASR, which is automatic speech recognition library, which is from OpenAI. And that's what's going to handle converting that. There's a lot of different problems that are involved with, like, figuring out, like, pronunciation, 4 miles. What does 4 miles mean? Is that like a distance of 4 miles, or what is it, like, in the context of music, maybe it could be 4 miles Davis, like, so it's like there's different, like, ways that things can be interpreted, and it has to do with context. And so this model has been pre-trained to figure out all of those things for you.
Yeah, that's exactly right. Like, more primitive ASR technologies would just use the pronunciation or the enunciation of a word to identify what's the most likely text it corresponds to. Like, another example would be knight and knight, the medieval warriors. It's not always easy to determine what was being spoken unless you keep the context around that word in mind as well. And this is what modern deep learning ASR models do. They not only listen to the single word and transcribe that, they also use the neighboring words to determine what's the best text it should be transcribing the audio to.
Great. Yeah. So then, once you've got all of the text, then from the conversation, basically translated from audio into text, you need to then create the summary of the input. So we're going to be using so that's that other, if you go back to the diagram, that would be the other model, the summarization model, which we'll be using to extract the key parts of that and to come up with the summary.
So at a high level, how these models work is, first, they have a general understanding of language, of English in this case. And these are called language models, actually, and you'll probably come across this term quite often now in context of GPT and all of that. But language models understand the general structure of a particular language. And then you take this general understanding of a particular language and fine-tune it for a particular task. In this case, summary generation is the specific task we are fine-tuning it to. So you start with a general language model, and then you fine-tune it to generate summaries. And the way you fine-tune that is by feeding it examples of what summaries look like. So there is a public data set called the CNN Daily Mail. I think the dataset consists of entire news articles and copy of blurbs for the news. So, it's a very good example to teach a general language model that, hey, this is what some good summarization looks like, and this is what I want you to be doing when I feed you any large piece of text. Which actually comes to the last bullet point. So, or this slide actually, that when you feed a large piece of text, as humans, we are almost unconsciously, we are not even aware of how we, immediately or instantaneously parse printed a word into a concept that we know of. For models, it's a little different. So you want to break it up into more discrete pieces of information, and this process is called tokenization. And tokens don't have to be just a word, like we tokenize concepts or in the English language with spacing or punctuation. But for models, they don't need just that. Like in this example, you can see ing in building is also a token on its own. So this process helps to make the text a little more easier to process for the model, and it's able to do its mathematical magic on these tokens.
Right. Because it helps it understand the language, right? Like build followed by ing, it's like, oh, okay, like it's an action verb, like.
Yeah, the way
So
I mean, we can probably not go too deep into this, but the way it on a high level does it is it looks at probabilities of these characters occurring quite often. So ing is a very common suffix, and it means something thing, and so ing is going to be a token of its own. And pi is a very common prefix for any Python related projects. So it determines that maybe this merits its own token, and that's kind of how, at a very high level, that's kind of how it tokenizes a language.
cool. So yeah, with that, you now know enough to get started on the next workshop. So let me clean this up so it's not, well, actually, we'll do it like this. So if you go to github.com FB samples, actually, you're probably already in that folder. So if you go up into the video summarizer folder and you click on the exercise there, that will take you to the exercise for the video synopsis generator. So let's see, what are we on time? It is, it's 11:44. Where's my schedule? Okay, so we are still about, oh wow, we're only 15 minutes behind now. So we picked up good. Okay. So let's do another 45 minutes on this workshop, and then we also have the benefit of lunch too. Okay. Actually, I think we're good. I think we can give the full hour.
Yeah, I think so.
Back after lunch.
And I think they would want the full hour for this notebook.
Yes. Yeah, this one's more complicated too. So okay, yeah. So let's do that. We'll set the workshop. It's 60 minutes, but technically you actually have until 1 p.m. Since that's when we'll get back from lunch. But again, we'll be monitoring the Discord, and if you have a question, you can jump on here.
Quick call out, Justin. So in the notebook, you will be downloading and generating files. You'll be downloading audio and video files. You'll be generating CSV files. And in Colab, you can access this from the option on the left. I have shared a screenshot of that on the Discord channel, but Justin, if you want, you can probably also open any Colab notebook and show our participants where they can look at the files from.
Right. Okay. Yeah. So I did bring up the Discord just to call out, like, there is a text channel for Video Summarizer. So if you go to the Video Summarizer section or channel, you can see that image there, and you can see there's this hamburger menu that you click on, and that will bring this out, and you'll actually be able to see the files. If I actually take you to Safari, here we go. This is where I have this is from the other lab, but you can see if I click this
still
here.
Sharing the presentation.
Oh, really? Why okay, there we go. Oh, I see. Is it only sharing? Okay. Can you see it now?
No.
Oh, okay. So I have to stop the share and then reshare again. All right. Gotta love technology. All right. So here we go. So if we go back in Discord, if you go to the Video Summarizer channel, there's a screenshot there. But if you go to in the workbook, if you click this button here, it shows that this is the table of contents. Where's oh yeah, if you click on the files, then it shows you the different files that have been downloaded. Again, this one is for the object detection.
Yeah, but it's the same thing, like it's Colab. So any files you generate, download, it's going to be in that folder logo icon on the left. So if you click that, you'll be able to access anything that you create. And you are going to be creating a few CSV files. That's why I thought it's important to just point this out. If you double click on the CSV files, you can also open a preview of it. within the collab itself, or even download it to your disk.
Yeah, I'm trying to figure where does the CSV get created? I probably have to have the
further down the line,
Yeah.
you'll probably have to run everything for that. But yeah,
Yeah.
that's kind of where it would be.
Yeah, I was gonna show like, oh, click this here, but no, I have to do too much work to get everything.
Yeah.
Yeah, so click on the hamburger menu and then click the folder, and you'll be able to see the CSV here.
And the audio and the video that you download. Any
Yes.
file, basically.
Yep, and in fact, you can, in the object detection one, you can see this was the image that we downloaded. All right, great. So again, we have 60 minutes for this workshop, but you actually have a little bit more time than that because we're going to be coming back at 1 o'clock for after lunch. So that gives you more time than 60. But yeah, make sure you're taking breaks, make sure that you're eating, and again, yeah, if you have any questions, ask away on Discord. Suraj and myself will be around, and yeah, if you have questions also on Zoom, we'll also answer here too as well. So, all right. I asked last time, and this time I'm like, oh,
that cue, yeah.
I just assumed you had it this time.
All right. So in this workshop, if you ran through the code, you downloaded a video and used an open source utility to extract audio, namely FFmpeg. And we used an ASR model from OpenAI to transcribe the spoken spoken speech into written text. So here you have your modality from audio to text. And then you use some NLP concepts like tokenization and summarization. So you stayed in the text modality and you essentially reduced the size and the verbosity of the transcription while hopefully still maintaining important topics and concepts in that passage. To do both of these, we used APIs from Whisper and Hugging Face transformers. Both of these are open source and freely available for everyone to use. And to make things tractable and for having the timestamps, the unsummarized transcripts, and the corresponding summaries, we used Pandas data frames to sort of have like a spreadsheet view of it. And this also allows us to very easily save it to CSV or do any further NLP processing or manipulation on this.
Cool. And so while everyone was working on the workshop, Suraj and I got the right idea to take the video recording of the session and use that as input and create a summary. So went ahead and created 2 slides to show the output of that. So this shows the timestamps. So Suraj, do you want to talk to the CSV file here?
Yeah. Justin, do you mind hiding column E? Because we don't really need those. No. Oh, it's a screen grab. Never mind.
Screenshot. Unfortunately, I can't.
Yeah,
Sorry.
I realized that. Yeah, I flubbered the formatting of the CSV, so that's on me. But essentially, we have each row corresponding to about 6 to 7 minutes of spoken speech, and column D has the actual transcriptions of what was said, and the last column has a summary of that. So if I just had to get a sense of what we had recorded earlier, all I need to do is read through column E, and it's probably a fraction of the number of words, right? Like half an hour's worth of video and speech in just maybe 150 words.
Yeah, that's nice. And on the next slide, I took a snippet of it. So Suraj actually stitched all of those summaries together, and I just further reduced it by cutting off the top and focused on the section on generative AI. But that's pretty cool. We now have a summary of the previous section of the workshop.
Wow, all of this has been distilled into just like this little pressy.
Yeah, those are the things that we covered. So pretty neat. We've taken so before we get into the next section, I just wanted to say again, thank you for spending time with us on a Saturday. I know we know that time is precious, and so thank you for being here. I'm always excited to be able to share AI and ML with people, and so it's I'm just really happy that you're here. We have put together a feedback form. I know that this URL is kind of ugly, but we'll also paste this into the Discord. But if you could fill out this form, it's only 3 questions, and your feedback helps us improve our content. So if you could take a moment to fill that out, that would be really helpful for us.
Yeah.
And also,
I added the feedback URL in the general channel of Discord, so easy to click from there.
Yes, and thank you again. Oh, Rama is coming on.
No, I just wanted to say, Justin and Suraj, thank you for spending your Saturday, doing this workshop for us all. So really appreciate it.
Yeah, and just wanted to say that this is the first time that we've created these materials for this workshop, and so we apologize for any problems and bugs that have come through. We've already identified a couple of them, and so thank you for your patience when dealing with those things and running into them. So
I thought the bugs were just sort of honey traps to see if people are actually
right, yes. Shoot, I should have just said that. I'm too honest. All right, so let's go on to the last section of the workshop for today. So we're going to continue our discussion about generative AI. And this next part, we're going to go deeper into an API that we've referred to earlier called OpenAI. So OpenAI, you may have heard of them. They're the ones who've created ChatGPT. Just quick show of hands from the tool. Like, how many of you are aware of? Actually, no. How many of you have used? Do you want to admit to this? Used ChatGPT? Raise your hand or select the yes button. All right, got a few people popping up, brave to admit that they're using AI tools to write stuff for them. I'm also raising my hand for that one too. Suraj raises both hands. So I don't think I really need to explain what ChatGPT is. There's a lot of really cool things and a lot of exploration. And so in this part of the workshop, we're going to go a little deeper into tapping into some of the API services that OpenAI provides. And you're actually in the workshop. It's actually split up into 2 parts. The first part is to create an account, which sounds like a lot of you already have an account. And then you'll be fetching an API key that you'll need to do the second part, which you'll actually call the Open API from some code to do something. So that way you have another way of interacting with their API instead of having to log into their front end. And if you look on the screenshot of their the Open API webpage now, you can see they've got a little thing there that says that the ChatGPT API is coming soon. So this will also help you be prepared for when that API becomes available. You'll be able to call ChatGPT from any code rather than just being able to go into the UI. So you'll have to make a few modifications to what we're sharing with you today in order to be able to do that. But you'll have the basic understanding of what you would need to do that when it becomes available. Cool. So OpenAPI, they're not just ChatGPT. They have a bunch of different things. They have images. They support that. So like DALL-E is one of those things where you can type in a prompt and it will generate an image that looks like that. So you can say like, draw a picture of a statue with a pigeon on its head, and it will generate that for you. So yes, they have a bunch of different things. And, another cool thing about ChatGPT is you can actually use it to generate code for you. So that's really cool as well. So a lot of different things.
Yeah, actually for today's notebooks also, if you were doing the exercises and if you actually took some of those hints and put it in ChatGPT, it might give you the right answer. Overwhelmingly, most of the times it does give you a really good answer. So you can use it to write code, and just by telling it what functionality you want, and it's pretty surprising how good it is.
Yep. So for those of you who have used ChatGPT, I'm sure you've done a lot of experimentation with it, asked it all a bunch of different questions. So I'm just going to go over at a high level some of the fun things that I've been experimenting with, and just sort of to share and make available. But in preparation for this workshop, I was just playing around, like asking it to hey, create a thing that says, that welcomes the guests. So it came up with a pretty good example here. I won't read it word for word, but it does a good job of welcoming you and sort of giving you an overview of what is to come. But then I decided to have a little bit of fun with it because its modality is text, and so it's like, ooh, how far can I take this? So my original request was welcome our Generative AI Workshop guests. So I modified that to be in the spirit of a pirate. And you can see how it changed the generated text. So instead of just being a generic welcome, it says ahoy mateys. It talks about being a pirate of the seven neural nets instead of,
and that's pretty cool.
And it's like, so hoist the black flag, grab your laptops, and let's sail to the high seas of artificial intelligence, and then R. So like that is super cool, that you're able to modify the output of that prompt. And so this sort of begs the question, like, if you're working with the AI and you first requested something, what do you do if the results come back to you incorrectly or not quite what you want? They do offer that mechanism. If you look to the to the right of the response, there's those thumbs up and thumbs down. Like you can submit feedback to make improvements, but you can also change the prompt, or since this works in a conversational style back and forth between you and the AI, you can actually say, oh, you know what, make it shorter, make it longer. So like you can always like tweak by, just asking for and giving it feedback manually, not just using the plus and minus system, the thumb up and thumb down, but just directing it. So that's an interesting thing to play with and to experiment with, which is just modifying your prompts and seeing how your prompts change the output. So one thing that ChatGPT does call out is that they don't have any data or knowledge of anything after 2021. So, there was something that I wanted to experiment with on that. It's like, okay, well, if I were to ask it about PyTorch 2.0, which was announced at the end of 2022, I knew that it wouldn't be able to tell me any specific details. But I thought, well, hey, if I want to, let's say I'm tasked with doing a speech at some sort of like conference, in this case, I'm just saying open source summit, why don't I just ask it to write an abstract, and instead of just saying write it about PyTorch 2.0, let me just fill in the gaps of its knowledge and let it know, okay, here are the things I want it to highlight, and these are features that are new. So basically some of these features are that, hey, PyTorch 2.0 is out, it's fully backwards compatible, it speeds up model training approximately 43%, and there's a new torch.compile API. So those are the things that I fed to it. And when it comes back, it actually comes up with a really good synopsis. And when I first created this and sent it over to Suraj, what was your reaction?
I was like, how did it know about 2.0? Like, we just launched it like 2 weeks back. And then Justin was like,
Yep,
oh,
and so it's like,
I filled in the gaps.
It's like, I know it has gaps in its knowledge, but it's like, it's a conversational thing. I can give it information and be like, summarize this. So
yeah, the interesting thing
know.
is ChatGPT, and in fact the latest GPT models, they have been trained on literally everything on the internet. Like, that's literally the training data set. So it's read all the web pages that are available, it's read all blogs, literally any article that's on the internet. So it has developed this understanding of how things work and a conceptual representation of different things that exist. So we can sort of feed it clues into what we want, even if it has not directly read it or parsed it during training, and it is able to sort of work that new knowledge into its existing understanding of the world derived from the internet.
Yeah, there's a whole lot of really interesting things that you can do there too. You can kind of think about like, okay, if you're writing something and you want it to be within a certain like target of audience, like, okay, I'm writing something that, somebody of high school, maybe I'm doing a talk for high school students. And so it's like, oh, it's been a while since I've been in high school. What is not only like the language that they're using, but like, what are the terms that like if I start speaking, are they going to understand, the different technical terms that I would speak? So it's like, you can modify the prompts to basically like run a filter through that and actually create something that is more approachable to a high school audience versus the audience that we're speaking to today. So it's one of those things where like that knowledge and understanding that it has from consuming everything from the internet like helps it like figure out how to not only like use different wording depending upon the audience, but also to like pull out information that you might not have asked it specifically to highlight, but because it knows about it, it can do that. And so I don't have an example of it in slides, but in one of my conversations, with ChatGPT, I asked it to like write about Suraj, who is a developer advocate for PyTorch. And in the response, it talked about how Suraj is also has a deep understanding of Python as well. And so it's like, oh, okay, like it ChatGPT understands that
of PyTorch,
the connection
Python,
between
and
PyTorch and Python.
Yeah, all of the concepts in this ecosystem of developer advocacy for PyTorch. Yeah.
Yeah, and I don't know if it knew that, like if it read any of your blog posts, Suraj. I imagine it did, and I don't know if it associated your name to any of those blog posts that you wrote. I have no way of telling that, but I did feed the gap by saying like write about and then your name, and then it used your name as the subject. So I don't know if it's doing anything with that, but I just thought that was interesting that it was able to make that association between Python and PyTorch. So cool. And then, here's some examples with coding. So I thought this was really interesting. So, I asked, because the old paradigm of whenever you were coding and you ran into a problem, you would go to Google and, you'd invariably find something on Stack Overflow, and that's where you go and you get your answer. But over time, will Stack Overflow be gradually used less and less, and will people go more towards ChatGPT? So that's an interesting question. I don't have the answer to it, but when I asked ChatGPT to reverse a string with Python, it did it with kind of a one-liner kind of thing, and I was like, I'm not sure how efficient that is. I don't know anything about how that's implemented under the hood. So I decided to follow the question. I didn't ask its time complexity, but it's like, maybe I want to do this with recursion instead of with the loop. So I basically said, can you do it manually using recursion? And so it comes back and does that. And so it wrote a recursive function. And so I thought, wow, this is pretty cool. Like, I'm able to just, it contextually knew what it was that I was talking about. I didn't have to say, reverse a string, like, can you manually do it? So with recursion, and it did. So I thought that was really interesting. So, and I'm pretty sure if I had asked, can you explain to me, what this does, or time complexities, having that understanding of all the different things that we could be able to associate with and give me that response.
Yeah, one quick thing I'd like to add here is, if you come across a snippet of code that you have trouble understanding, what each line is doing, you just copy and paste that into ChatGPT's text box, and you ask it to explain line by line all of the functionality in this code snippet. And it does a pretty good job of that. It's not seen that code snippet before, but it'll still know what's happening and make connections with different variables that you have stored and different data structures that you're using to get a sense, or at least portray that it has got a sense of what you're trying to do, and explain that in a very nice way.
Yeah, and so another interesting fun thing to do is what I think is interesting is you've got that dichotomy in your brain between left brain and right brain, and so it's like, this is definitely the whole process of creating an AI is left brain, and you can use this product of the left brain to generate right brain type of content. And so I was playing around with a little bit of poetry, and I was asking about hey, write a haiku about cats in the style of a Jimi Hendrix song. So it's kind of fun. You can do some of these really weird sort of combinations of subjects in the style of. It kind of reminds me of an improv show. If you've ever watched the show Whose Line Is It Anyway? I don't know. I was just laughing and imagining what would happen if you were to put people together, and on that show they would have people in the audience come up with topics. What if you had an AI doing that or coming up with things? But I thought the resulting haiku was actually pretty interesting. And one thing that I did go through was I checked to make sure that it actually was 575, and in this example it was. Unfortunately, Suraj, when we were playing with this together, I can't remember what our prompt was, but we had prompted it, and it came back 565 or something like that. It wasn't quite right. Yeah.
Just
so
off by a bit.
Yeah, so that's another thing to think about with AI and generative AI and what ChatGPT is doing. It's not everything is guaranteed to be perfect. So, if you're out there and you're like, yes, I want to use ChatGPT for everything and never want to write anything ever again, I would advise that you don't do that, because you might end up making a fool of yourself with something that's not quite correct, or comes up with. There's been a few times where I've had it generate something for me and it used language, and I'm just like, it was just really long-winded. It's like, we can cut this down. And so then that begs the question, should I manually trim it down or should I ask ChatGPT to trim it down? So there's it's an interesting, question to ask. And I think each person who uses it's going to have their own way and method of how they trim and use the output. Cool. So with that, we're going to move into our workshop. So as I said before, we're going to be using one of the open APIs. Actually, Suraj, I don't think I mentioned what it is that they're actually going to be doing with that API. Do you want to take a stab at what?
We aren't using the API just yet. I think for now, if ChatGPT is it's available, then we'll just have everyone get their hands dirty, try out a few prompts, maybe just like for 15 minutes, just get a sense of what the model does. Is that something?
Sorry. What I meant was like because there's two parts, right? The first is getting the API key, but part two of the workshop, like the end result, like what is it that they're going to walk away with?
Oh, I love it. Someone's already posted on Discord their attempt to get ChatGPT to explain Python code. I don't know. What do you think? Is this explanation did it make sense to you? 1729. Sorry, Justin. I didn't want to interrupt you.
It's all good. I don't know who 1729 is, but if they want to talk about it, go ahead. We want to make this as conversational, so feel free if you want to share. If not, that's okay too.
I think this explanation is it's quite nice, personally.
What was the question, and what I can't see on?
It was one of the lines of 1729 says that was a good explanation, and it was one of the lines of code in our summarization notebook about checking whether the token length was more than the permissible number.
Yeah. The slice will contain elements index I.
One thing I do notice is that it hasn't explained what tokenizer.decode does, and that's probably because it didn't have enough context to know what NLP tokenizer the variable refers to. Perhaps.
Yeah, that's one of those things where it'd be interesting to ask it and see what it says.
Yeah. By the way, with these large language models, like they're in a class of their own because they're like really large. So like a few trillion to hundreds of billions parameters, very huge models trained over a lot of data, and researchers are noticing properties that they can't fully explain. All of these properties are termed under emergent properties because they seem to emerge when the models exceed a certain size. So that's a very interesting space if you wanted to read a little more about this.
Okay. So with the workshop, this next one we're going to do in two different parts, and what you're going to end up with is what it says here on the slide, that generative AI is a creative partner. Ooh, sounds pretty cool. So I kind of this earlier, but like you'll be able to have some code that you'll be able to run that will allow you to do some certain things, like actually one of them is based upon like different ingredients that you have at your disposal. It can recommend like a cocktail to make. And that's using the Open API API to do that. There's a few other functions. Suraj, what are some of the other things that they'll be able to do?
In the next workshop, like the part 2 of this.
Yes, yeah, because once they complete part 1 and part 2, they'll have the tools. So I just wanted to tease as to what the output of following both 1 and 2 does.
Yeah, part 2, I mean, by default, it can help you create an advertising campaign. It can help you create new cocktails depending on what you have in your bar. It can give you, it can be a PyTorch coding guide. And honestly, it can be anything that you want, and we'll show you how you can build that into the tool.
Cool. Yeah. So we're going to do this one in 2 parts. And the first part will be getting your API key. So for those of you who already have a ChatGPT account, congratulations, you've already finished the first step. For those of you who don't have a ChatGPT account, you're going to create one. And well, actually, you'll create an open API. And once you do that, you have access to ChatGPT. Just want to point out, like, once you've, I'll have the link to where you create your account on another slide. But once you've created your account, you want to pay attention to these next few slides to figure out and understand where your key is going to be generated, because that's the first task that you're going to do, is to create. It's 2 parts: create your account and get your task. Get your API key. So once you've created your account, you've logged in, you'll see up in the upper right-hand corner, it'll say, your initial of your account name, and then I don't know if it's personal. That depends on whether you have a personal, or I don't know if they have educational accounts or what. But anyway, you'll click on that, and a menu will pop up, and it'll say view or create API keys, depending upon whether you've done that before. You click on that. I've got a red box around that on the screen here. Once you click on that, I already have an API key created, so you most likely won't. So you'll click that plus create new secret key button, and once you do that, that will come up. I've blocked mine here because it's private, but one thing to note is this is a one-time deal. Once you click this, it doesn't get saved anywhere, and you can't have access to the full key anymore. So you'll want to copy and save that somewhere. It's okay if you forget to save it, because you can always generate more keys and delete your old ones. But when you get to this screen, you'll want to make sure that you click the green copy box there or button and paste it into a file. So just wanted to call that out, and we'll be on Discord for those who get stuck if you forget how to, or if say you forgot to save your API key. So for this part, it's only about 5 minutes, but you'll basically go to the URL there, openai.com/API. If you don't already have an account, create an account. If you have one, you'll go in and create your key, and then you can play with ChatGPT. So I got write a story there. So you can have it write a story, you can have it write a haiku, whatever you want it to do. Have it explain to you code. And it looks like we have a few questions here. So I saw Tony's hand first.
Hi, sorry. Could you share the Discord link again?
Yes. I'll put it up on a slide. I know it was earlier in the presentation. Here it is. There's the Discord URL. Discord.gg. And then I thought I saw one other hand go up. Was that Iris?
Yes. I have the same question.
Okay.
As Tony.
Great. Okay. All right. So, yeah, this one's only 5 minutes. It should be pretty quick. So we'll meet back up at, oh, wow, look at that. Is that at 1:45? I'm sorry. I'm 3 hours behind you all.
1:45.
1:45.
East
All
Coast man.
right. Yes.
Sorry, about the Discord. I think it's expired.
Oh, it has? Let's see.
Need to send a new link.
Discord works for me.
Here, you know, I'm gonna do this. Where's the other slide with the Discord? I'm gonna copy and paste it on. Where'd that go? There it is. There you go. All right. So at 1:45 Eastern, we'll be back. Oops. Match this case with advertise. If you arrow to advertise, you click on that, the text for advertise will appear, and you'll provide that product, which is the
And Justin, you could actually just run this tool as well. So if you go to the shell option on the right, and
so we're in REPL or Replit, and we clicked on shell.
yeah, and if you just type Python space main underscore solution dot py and hit enter.
All right, what do we want for a product? A square peg in a round hole.
Yeah, let's do
it. Let's see if it comes up with the famous. Oops, I can't spell. Oops, what happened?
Oh, your API key.
Oh, right.
Your top secret API key.
Yes. So I don't have my API key saved in a spot to get. So I'd have to generate a new one, which I can. But I think at this point we can turn it over to the attendees. So
Okay,
once you have your API key in here, you can run it with main solution. Another cool thing is you can actually ask, like, you know, you could run main solution without looking at the code and ask, like, how can I make an API call to access the Open API OpenAI API and see what code it gives back to you. Go from there. So yeah. Cool. All right, I'm gonna put the slide back with the instructions, and I think I hear some Discord questions coming through. So check Discord. All right. Nice. All right, we got some chatter there. Okay, cool. General, any questions? All right, cool. Okay. All right. So yeah, 45 minutes. That puts us right at almost 3 o'clock. So I know we wanted to reserve time for Q&A, and that only gives us like 5 minutes or so. Do we want to push this like shorten this a little bit so we can have a little bit more time for
Yeah, I think since all of us have a pretty good sense of GPT, we could probably shorten this down to, I guess, 30 minutes, I guess.
Okay. Yeah, and that gives more time for discussion after. Cool. All right. So that will bring us at 2:45. Technically 2:43, but
And like before,
right.
please share your screenshots on the channel on Discord. It's always interesting to see, how creative humans and then the AI responses are. So please do share.
Yes. Thank you. That's fine. One of the great things about this workshop is we have all of the assets available. So, you're not beholden to, only having access to them during this time. So, you can take your time, go back through, take a look through them, and you can continue learning at your own pace. Suraj and I are continuing to work on these example projects. We plan to be using them at other future workshops, and so we may update them from time to time. So for those of you who are following along, you can star the repos. And I think starring, do they get any sort of notification when we make a change? I believe so.
Yeah, they'll just get a notification on the GitHub homepage. No spam on the emails, but yeah, they can follow along with any new changes or if we add anything new, any updates on that.
Cool. So yeah,
I also just wanted to call out, I'm super appreciative of all our participants because I know a lot of them, they're not programming first people. We have some students from the business school who are new to programming and they still stuck through, and these weren't easy workshops by any means. These are fairly advanced concepts, in fact very very new and cutting edge concepts, and it's a big deal to actually put your head down and write code on this, so I'm super appreciative of that.
Yeah, thanks. I couldn't have said that any better myself. Yeah, it's interesting, right? Because you bring up the fact that it's a new and emerging field, and it's so new that if you try to do search and dive deep into some things, it can be hard to find some materials about it. So it's a lot of it have to dive deep, or it's so new that it hasn't been written in a way that people who are not very, very close to AI can understand it. So, there's a lot of stuff, and it's rapidly changing, and things are just moving at a high pace too. So,
yeah, things are moving really fast. Before they can even consolidate as a standardized knowledge base of capabilities and things you can do with this. Boom, you got the next new thing. So it's really fast. It's moving really fast. So props to you. Oh, Aditi, you have your hand raised.
Hi. Thanks so much for this workshop. I'm a lawyer, and I could just understand what you were doing. And I just want to know, would you be putting this up, because I intend to practice this, and would you be putting this up somewhere where I can access and take help of my friends who are more conversant with GitHub? I just know basics of it.
Sure.
Yeah, we'll have all of the code that you saw here today on GitHub, but perhaps we might also have a blog post, walking you through this, so you can do this asynchronously. You don't need us talking you through this stuff. And we'll also have the video. So we've recorded this session and we'll be sharing that with Rama and Steven. So in case you wanted to, have this as a reference, you can use that too. And it's interesting that you say you're a lawyer, because I'm actually writing a blog about something that might be useful to you, or really anyone who has to deal with a lot of text documents and they just want an easy way to retrieve information from that in a more conversant and semantically pleasing way than searching through troves of text and code. So another way, a really good way for you to stay in sync would probably be to follow us on Twitter. We post quite often over there on all of the things that we have been building and all of these little tools, and that's one way that we can stay updated.
Oh, great! Thanks so much.
Yeah, so I just put up on the slide here our information where you can find us and follow us. These are the PyTorch channels. So you got PyTorch on Twitter, LinkedIn, Facebook, the GitHub, and the events page. If you follow the events page, there's virtual events and also in-person events there as well. So I recommend bookmarking that and checking it out and seeing if there's any sort of things that pop up in your area or something virtually to further expand upon your knowledge.
And we also have our personal social media accounts somewhere, either on the next slide or next to.
I'll take it to the intro slide, because the other slide says thank you, and we're not quite ready to dismiss everyone yet. So if I have the thank you slide show up, people might be like, oh, it's time to go. Click. So there's our Twitter handles. You can also find me on LinkedIn too. All right. Great. So, I see Rama, you signed. Do you have any questions or comments? Oh, I think you're muted.
Yeah. I just want to say this has been really nice. Thank you so much, both of you, Suraj, Justin, for putting it together. I think, obviously, we covered a lot of ground. We went from the basics of, a rank 0 tensor is just a scalar, all the way to, doing object detection and video summarization in a massive pipeline using 2 different deep learning models in the pipeline and so on. I maybe just to add to what Suraj said in response to Aditi's question, I think these collabs, the Jupyter notebooks, I would really view them as sort of this sort of renewable resource. It's so for example, I've been doing programming for a long time, and when I look at a new Jupyter notebook, it actually takes me multiple passes through it before I actually understand what's going on. Particularly if you're new to programming, I would strongly encourage you to literally take each line of code in the collab and run it and make sure you understand what is going into that line and what's coming out of that line. Yeah. So break up the code into little lines, go through each one of them, understand exactly how sort of what went into the line got transformed into what came out of that line. And while it may be painstaking in the beginning, I find that to be an incredible way to understand what exactly is going on. And it may take multiple passes through the notebook to get to that point. And I think, one useful thing, which actually I was already doing as the workshop was in progress, after Suraj pointed out, the whole sort of, you can ask ChatGPT to explain code to you. I think that's actually a great way to learn, because if you see a line in one of the notebooks you don't quite understand, just ask ChatGPT to explain it, and it actually may help. And I find the explanations, again, I tried like 5 times, n equals 5, not a big sample size, but it's actually quite promising. And so I just want to say, plan on, if you really want to learn this stuff, you do need to sort of, marinate in it for a very, very long period of time. And so I certainly, don't be dismayed if the first pass through the notebook isn't super clear. Plan on doing multiple passes through the notebook. Trust me, the experts do it exactly that way. before they understand any of this stuff. So I just want to encourage people to take these resources and sort of think of this workshop as really the starting point for learning about it, and then repeatedly going through them and trying to understand what's going on.
Thanks, Professor.
Of course.
Yeah, that's a really good point about how notebooks are, interactive in that sense. And if you have worked on programming languages before, Python makes it really easy to do this one line at a time. So you can just take one line out, have it in its own cell, tweak something to see how it looks. The learning curve sort of flattens out a little more when you get to hands-on play with things and see how it changes. All right, so we are wrapping up our final workshop, and here we learned how to create your own personal customizable in-house assistant that's been supercharged with GPT. To do this, we called the GPT API from Python, bypassing the need to actually open the chat API, chat playground or website. We also learned about perhaps a new tool, Questionary, that helps us build pretty command line tools, so we don't have to invest in building out a whole UI. And we also tried this on Replit, which is a nice IDE where you can run Python code on the cloud, so you don't have to actually have those dependencies or any of those libraries on your own desktop. So you have this on the go wherever you are, even if you don't have your personal laptop at hand. Right?
Great. Yep. Yeah. And then we sort of already moved ahead and revealed this slide early, but this is where you can follow PyTorch. So yeah, you can be all various places. You can screenshot this slide, and you'll know where to find us. And lastly, we've seen quite a few people have already filled out the feedback form. So again, thank you so much for doing that. If you haven't done so, the link is also in the Discord. And so yes, this is the first time we've ran this workshop, so it's very helpful for you to give us any feedback. We've already identified a few things that we need to update in the workbooks, and so we will be doing that.
And so, like we mentioned, we are going to keep these resources alive. We are going to keep updating them. So they're going to be evolving as we, share this workshop with more people. So again, your feedback is really going to help us, refine this and make this more approachable to wider audiences than programmers, which is really the goal over here. We want to share, these techniques and these approaches with a more diverse group of people, and selfishly, because that really only forwards the industry as a whole, and it brings very diverse perspectives on how these technologies and how these techniques can be used in very different ways. So that's kind of our hope over here. We wanted to bring you in on the ground floor and take you all the way to where it is at right now, and keep trying to provide you the tools to further your journey down this very exciting space.
Yeah, and to that point, if you're really, part of the reason why we want to expand the understanding beyond the scope of software development, beyond the scope of engineers, is because there's a lot of areas and where AI can lend a hand and help make improvements and help so it's for example, we talked about in the case studies with farming, with the automated weed detection and spraying of pesticides. There's a lot of business cases where AI could help make things more efficient, cut costs and things. And by cutting costs, I don't mean cutting corners. I mean optimizing something in an efficient way that actually brings that improvement and brings that in more capital. And so there's a lot of applications that can be used for this. And so it's like getting more and more people outside of, you know, the computer science and engineering fields, but, you know, like involved in understanding like what are the capabilities of AI, like what it is, what it can do, will help drive like, oh, hey, you know, we have this problem that we can solve. Can we use AI to do it? Yes, we can. Okay, now what resources do we need? Who do we need to bring on to do that? Like, so it can help with that. So I would recommend for those of you who, you know, who have an interest or who are, you know, from a different background, whether you're a lawyer, whether you're in business, take a look at the case studies and for just some inspiration. You know, I went over 2 of them today, but there are a lot more in that page, and I'm trying to find the slide while I'm talking. But here it is. So if you go to the pytorch.org/community stories, you'll find a bunch of different use cases here where, you know, there's real world examples where AI is making improvements and furthering along development in different sectors. Right. All right. Well, thank you very much for having us. And again, thank you for spending your Saturday with us.
Thank you, Suraj and Justin, for spending your Saturday with us and taking us through this fantastic and deep material. I think it's a gift that's going to keep on giving. I certainly plan to revisit it, and I certainly plan to liberally use it in my own teaching. So thank you. And all the attendees, thank you for taking time on your Saturday to join us for the workshop. I know that, you know, the folks in the audience had very different prior programming backgrounds as well as sort of knowledge of machine learning and deep learning. But I really admire your courage in actually joining the workshop and just, you know, sort of grappling with it, knowing that it's really the beginning of the journey. So I'm thankful to all the attendees as well. Stephen, did you want to, Bruce, did you folks want to chime in?
Yeah, big thanks to Serge and Justin for this. This has been quite a few months in the making, and you know, spend a Saturday here with MIT and give us these tools for later on. It's really incredible. I know I'll be revisiting this later on in the future. Checking out the GitHub seems very useful, and we really do appreciate having you this year.
Yeah. Thank you.
Great. Thank you. All right. All right. Bye, everyone.
All right. Thanks everyone.
Bye.
Thank you.
Thanks again.